Alright, so some of you mentioned to me that the stuff we talked about in class on Tuesday was a little bit confusing, and I've got a new toy here, so I'm going to try and help you understand this by recording a video where I actually work out the odd number problems in your problem set. Hopefully this helps by helping you go through the thought process. So number one says an electron in a certain atom is in the n equals 2 quantum level. List the possible values of L and m sub L that it can have. Well, I've got to start when I'm working this problem realizing that I've got the n equals 2 level. That dictates what my L values can be, because my L values are always from 0 to 1 less than n. So in this case, from 0 to 1 less than 2. So 0 and 1. Okay, indicating that at the n equals 2 level, I can have s and p orbitals. Now, my m sub L values in class, we used a little formula where we said m sub L is equal to 2 times L plus 1 to give me the number of values or orbitals. We don't necessarily have to do that. Let's try and make it a little simpler, and let's just go straight to what the actual values are. And let's just keep in mind that m sub L values will always be from minus L to plus L. So if L is 0, then the only m sub L value that I can have corresponding to that would be from minus 0 to 0, or simply 0. So that's possible m sub L value. Now, when L is equal to 1, so L equal to 1 here, my m sub L values are going to range from minus L, which is minus 1, all the way to plus L, which is positive 1, so minus 1, 0, and 1. I have 3 different values. Each one corresponds to a different p orbital. So the final answer to my question would be the possible values of L right here are 0 and 1, and the possible values of m sub L range from minus 1 all the way to 1. Number 3 says give the values of the 4 quantum numbers of an electron in the following orbitals. So let's take A and look at it. A is a 2p orbital. The 2 in front of the p tells us right then our principal quantum number of n is equal to 2. The p tells me what L is, right? If L is 0, it's an s orbital. If L is 1, it's a p orbital. Now, for m sub L, right now, I just have to list my possible values. So when L is 1, it ranges from minus L, or minus 1, all the way to plus L, or plus 1. So each value here corresponds to a p orbital. I've got 3 p orbitals that electron could be in. And then finally, m sub s, all right, is always either going to be plus 1/2 or minus 1/2. Let's try B now. I'm going to play and change colors. I like blue. So let's look at B. Oh yeah. So B is list the values of the 4 quantum numbers for an electron in a 3s orbital. N is equal to 3. L, since it's an s orbital, has to be 0. M sub L here ranges from minus L to plus L. When L is 0, it can only be 0. The spin quantum number, m sub s, is either plus 1/2 or minus 1/2. All right, move it along. Let's look at C. So a 5d orbital. N equal to 5. L, if it's an s orbital, it's 0. If it's a p orbital, it's 1. If it's a d orbital, it's 2. My m sub L values for an electron in a d orbital are going to range from minus L all the way to plus L. There's 5 different values because there are 5 different d orbitals there. And finally, m sub s values will either be plus 1/2 or minus 1/2. Alright, so number 5, here's a doozy. It says list all the possible orbitals associated with the principal quantum number n if n equals 5. First thing I have to do is determine the types of orbitals I can have by finding my L values. So L ranges from 0 to 1 less than 5. So 0 to 4. That's an S, P, D, F, and G orbitals. Okay? The way that I will get the total number of orbitals, the total types of orbitals and everything, is to simply find the m sub L values for L equal to 0, the m sub L values for L equal to 1, the m sub L values for L equal to 2, 3, and 4. So let's try that. Separate it here. If L is equal to 0, m sub L can only range from minus L to L, so it can only be 0. So that's 1s orbital. 1s orbital. I think I might run out of room. If L is equal to 1, my m sub L values can be minus 1, 0, and 1, minus L to L, corresponding to 3 p orbitals. Okay. Next, if L is equal to 2, then my m sub L values, my range will be minus 2 to positive 2. For 5, there's 1, 2, 3, 4, 5 different values, 5 d orbitals. Ooh, it's getting ugly. If L is equal to 3, corresponds to f orbitals. My m sub L values will range from minus 3 all the way to positive 3. There's 7 different values for 7 f orbitals. And then finally, if L is equal to 4, my m sub L values will range from minus 4 all the way to positive 4. Okay, which is a total of 9 g orbitals. So the final answer would be I've listed all the possible orbitals. To get my total number, I would just add them up. There's 1s orbital, 3 p orbitals, let's make 4, 5 d orbitals for 9, 7 f orbitals for a total of 16, and 9 g orbitals for a total of 25. Moving on to number 2, it's a lot easier. If only a max of 2 electrons can be in any specific orbital, calculate the total number of electrons that can occupy, A says simply 1s orbital. It doesn't matter if it's an s orbital, a p orbital, an f orbital. If it's a single orbital, it can hold 2 electrons. B says 3 p orbitals. Well, each orbital can hold 2. If there's 3 of them, that's a total of 6 electrons. C, 5 d orbitals, well, 5 times 2 would be 10 electrons. And D, 7 f orbitals, so each one can have 2. 7 times 2 would be 14 total electrons. All right, last 2 problems here. Number 9 says how many p orbitals are there in n equals 1 level, n equals 2 level, and so on. This is kind of a trick question. Okay. Well, for A, if n is equal to 1, then I know the only possible L value I can have is 0. which corresponds to an s orbital. So therefore the answer to number 1 would be 0. B, n equals 2 level. Well, if n equals 2, I know it's a p orbital, then L is always going to equal 1 if I can have it. It doesn't matter if it's the n equals 2 level, n equals 5 level, n equals 10 level. If I'm talking about p orbitals, my L quantum number for a p orbital will always be 1. And that's what determines the number of p orbitals I can have at any given level. So if L is 1, my m sub L values will range from -1 to 1. So that means there are 1, 2, 3 p orbitals. Ooh, I got kind of messy there. Now for C, if n is equal to 3, okay, my L for a p orbital has to be 1. For D, if n is equal to 15, still L for a p orbital has to be 1. So for C, my m sub L range is -1, 0, and 1 for 3 p orbitals. Same thing with D. If n is 15, L is still got to be equal to 1. And my m sub L values are -1, 0, and 1 for those 3 p orbitals. Number 11, there's 2 ways to work these. I'm going to do one the long way and then the rest the short way. So how many total orbitals are there at the n equals 4 level? Well, what I have to do to solve A is if n is equal to 4, I have to first of all write all the possible L values for all the possible orbitals I can have. 0, 1, 2, and 3. So S, P, D, and F orbitals are possible there. The way that I get the total number of orbitals is if I add up all my m sub L values. So if L is equal to 0, I only have one m sub L value of 0. If L is equal to 1, then I can have m sub L values equal to -1, 0, and 1. If L is equal to 2, I can have m sub L values ranging from -2 to +2. And finally, if L is equal to 3, I can have m sub L values ranging from -3 all the way to +3. Now what this corresponds to is, let me get a different color. Trying. What this corresponds to is 1 s orbital, 3 p orbitals, 5 d orbitals, and 7 f orbitals. So that would be a total of 1 plus 3 plus 5 plus 7. So that would be 16 total orbitals. Now the easy way to do that is to simply use the formula n squared to give you our total number of orbitals. So if n is 4, 4 squared equals 16 orbitals. So that's a little bit easier. So when I go to B here, if n is equal to 5, you can do it the long way, like what's in green, or you can say 5 squared will give me 25 orbitals. And lastly, if n is 7, 7 squared will give me 49 orbitals. Have fun if you write all that out.